Hi there. Today we'll learn our third lesson of computers. This will be divided into two sections. In the first section, we'll go over what we learned so far and summarize it, and we'll talk a little bit about computer history. And in the second session, we'll learn more about the construction of a computer, and we'll see what it's used for and how it works. So let's begin with the first section. And if you remember, we spoke about several topics in the first two sessions. One of them was the difference between hardware and software. And if you remember, we said that hardware is basically the machine itself and whatever material it's made of. It could be metal, it could be plastic, it could be glass. Inside you have all kind of wires, you have a disk, etc., etc. This is the hardware piece, and software was the stuff that we cannot see, and we said that software is actually something that's inside the computer, and no computer can function without software, so it's a very important part of the computer. And we didn't touch on what exactly the software is made of. We just said that it's the general large program that almost every computer has is called the operating system, if you remember, and we abbreviated it as OS for operating system. And different computers have different operating systems. Some that you know, for example, Windows is one of them, and I'm sure you know that the Mac also has an operating system, and the Mac's operating system is called simply Mac OS, and they try for marketing reasons to give all kind of fancy name like Leopard or Tiger. The latest operating system for Mac is called Snow Leopard, but it doesn't matter. And there's also another operating system that's quite popular. It's called Linux, and Linux is free, and we'll talk about free software later on. But Mac, OS, and Windows cost money, and Linux is free. So that's about operating systems, and we also said that operating system is what manages everything inside the computer. We'll talk about it much more later on. We also mentioned something that's called an algorithm, which is a very, very important term. And we said that algorithm is basically a set of instructions that each instruction can be interpreted only one way and must be very clear and precise, and it accomplishes something, and it's a finite set of instructions, so it can't go forever, but it ends at some point, and when it ends, it accomplishes something. That something should be a useful purpose, and this is why we want to write an algorithm. And later on we'll see that we can take an algorithm and translate it one-to-one into a computer program. And basically, if you want to write a program that's very complex, it's advisable to first write the algorithm for it and then translate it into the computer programming language. And another thing that we talked about was binary code or binary counting method, and we made the comparison between decimal system, which is the counting system from 0 to 9 with 10 symbols, versus binary, which only uses 2 symbols. And if you remember, the binary symbols were 1 and 0. So just as a reminder, we count in binary, we say 0, and then we say 1, and the next number after 1 is not 2 because we only have 1s and 0s, but the next number would be 10, and the next number after that would be 11, and the next number after that would already be 100. So if we translate it to decimal, this would be 0, this would be 1, this would be 2, this would be 3, this would be 4, etc. So you had the exercise on that and homework, and hopefully you did it correctly, so we don't need to dwell on this. Now, let's talk a little bit about the history of computing. It's normally customary to credit a man by the name Charles Babbage from London, England. Here's his drawing, I guess, maybe his picture. And he lived in, he was born in 1791, which is quite a long time ago. And he basically invented a machine that's a mechanical machine that looks like this over here, that's considered the first computer. And that was around the year 1840. It wasn't electronic, it was mechanical with a lot of parts that are intermingled together, and it did some sophisticated things, but it's not like the computers that we know today that are electronic computers. And by the way, the first programmer is considered a woman by the name Ada Lovelace, and after her name, she worked on that machine that Babbage invented. And after her first name, there is a programming language that's called Ada. So this is a bit of history, and now if we fast forward to the electronic age, there is another man from England who's considered the inventor of the electronic computer, and his name is Alan Turing, and he's from Manchester, England, and he was a mathematician, and he worked during World War II on a machine that was one of the first computers, and that machine's purpose was to try and decipher the code that the Germans, the Nazis, were broadcasting to their airplanes to bomb England. And by deciphering the code, they could warn the different citizens in different locations in England and have them evacuate that area. So that machine, that first computer, was very, very useful. And of course, Alan Turing and a few other scientists that work on that computer were able to save a lot of lives as a result of the computer calculating the code and translating it into real locations. So a bit of history. Actually, there is a prize after Alan Turing. It's called the Alan Turing Prize, and this is equivalent to a Nobel Prize in other sciences. This is the highest prize in computer science in the world. And there was even a professor in my department that unfortunately died this year or only last year, but he was a winner of the Alan Turing Prize. So anyway, that's enough for history, and in the second section we'll talk about how the computer looks like and how it's built, and I'll show you some schemas, and we take it from there. So for now, I'll stop the recording, and I'll start a new one for the second section.